and catch the eventual outcome. So a promise is a mechanism to run an asynchronous process and then have an easy way of getting out the data when it's ready. Morten tells me they call this an explicit future, but I'm not entirely sure if what I'm going to show you today is what they had in mind. So, isolation futures. The advantage of these, well, we've heard a lot of talk about isolation futures today, and it probably doesn't come as a surprise to you that isolates run in a separate process. So it's not the same main process that you're running your application in, which of course gives you the advantage that it can make use of multiple cores on the same machine. So if you've got heavy calculations to run, starting up separate processes and run them enables true parallelization. So yes, as I said, it's only really useful when you've got some heavy calculations that you're doing in APL and you want to speed up the process by splitting the work. Promises, on the other hand, run in the same main process, so they're basically limited to a single core on your machine. The lightweight thread management, which is basically what Klaus just demonstrated. How do you deal with threads in your application? And he's shown us about 6 different mechanisms to do that. I'm going to show you one. So when would you use promises? If you don't want to use it for heavyweight CPU-intensive operations, there's little room for other use cases, and these would typically be I/O operations where you're requesting some data off the network, if it's a web service, or some slow network drives that you're retrieving files from or copying files, etc., where your APL isn't doing much work, but the environment or surrounding environment is keeping your code from proceeding. So, right, I've just mentioned these user I/O I put there, but I think while you're in the APL environment, the WinForm GUI is already giving you lots of mechanisms to deal with that, so there's probably not much gain in the aspect of user input-output. I've created a model in APL which is using a new operator as a cover for the ampersand. It returns a promise namespace immediately, which has a few different names that are used. The state is a scalar number indicating the current state of the promise. So it's either pending, or it's been resolved, or it crashed and burned. The value contains the actual eventual outcome of running this function asynchronously. So it's implemented as an eladic function, which will block until the promise has resolved. And finally, the dyadic operator then, which is used for chaining promises. Now, a simple example of how you would call that, you've got a function here. I'll stick to everyone else's examples of using QuadDL. We use QuadDL here. It takes a single argument, which is passed to the right-hand side of the operator, just like you would with ampersand. It returns an immediate response, which is this P namespace. And if we check the state of that immediately after calling, we get the neg1, and asking for the value blocks until it's completed. And we can apply that derived function to a vector of arguments. So 1, 5, 10, again, returns a vector of promises, which I assign to P. And if I ask for the first promise value, it will block for a second before returning that result. Broken promises. The operands in the call to these tools are called under a general trap in a traditional function, making sure that anything that's signaling an error is caught, and if that happens, it sets the value to quad DMX. I'm not entirely sure what happens there, if it's a copy of that threads object or a reference to that threads object. But it seemed to work, so I'll stick with that. And it also sets the state to 1. And if we look at an example there, there's a protocol where we divide by 1, 0, and 10. The state indicates that the first and last one were successful, the second one failed. And if we look at the value, we see the result. This is a display format of quad DMX, so it's actually an object you can interrogate to find out the specific error number or the internal messages, etc. Chain promises. I briefly mentioned the then operator, so it's a mechanism of chaining function calls. The left operand is an error handler, and the right operand is the next function to call once the first one has completed, as it were. And this one also returns a promise. So in my simple example, again, I'm using the delay, and it's got the argument of 2 seconds, and immediately after that I chain it, and I say when P1 has resolved, then execute this encode to get the fractional part of the value, and on error just return the error. And because it's an operator, I also have to pass it an argument which is currently ignored. And if we ask for the value of P2, which is the chained promise, we, after a couple of seconds have passed, get the result 0.007, which is the total time that quad delay reported. And these chained functions are basically queued up and executed once the parent is fulfilled. So P2, these operands here are just held in reserve until P1 has resolved. The functions are called monadically with the result of the previous one, so P dot value. Broken chains. Right. As I showed before, you can attach, or you have to attach an error handler to when you call the then operator. So you have to provide some sort of a function, even if it doesn't do anything. So in my case, I just use the write tag to return the error message. But with the current model I have, that leads to an interesting little problem. Where we use the example of reciprocal again. I create 3 promises, 2, 0, and -2, and P1 is then chained to create P2, which is taking the fractional part of the result, and P3 is then multiplying that by 1,000. And both P2 and P3 error handlers are just returning the argument that they get passed in. Looking at the state of these 3 promises, we can see that the second item failed in the first one. The second promise reports all okay on all accounts, and the third one failed on the second one. And looking at the individual values of those promises, we again can see divide by 0 was the error in the first instance. The second instance reports that error. With the third one reports a domain error. And the reason for that is that the third promise, when inspecting which function to call, if it's the error handler or the next function, looks up the chain and says, well, P2 handled the error, okay, it reported that everything was okay, therefore it was okay, and I'll call my function. So it tries to multiply the error message object with 1,000, which doesn't work. And that's arguably the right behavior. because an error handler might actually try to resolve the issue that was caused in the first instance and return a valid result. And if it can't, then it should signal an error. But that's basically concluding my presentation. It was an experiment just to see how you avoid using threads explicitly and tokens, and not have to dabble with T4, which I think if I had seen your library, I would just have stuck with that and forgotten about promises. But I'd like to see something that makes it easier to work with threads like this. And I really like the idea of the futures, because what the futures give you that my model doesn't is the built-in ability to restructure the result and use futures in a complex structure without blocking. And I can't do that.
On the other hand, they don't give you the way to specify an error handler step. I don't know whether that's important or not.
When I found a use case for it, I'll tell you.
I mean, essentially, the way I understand these promises, they are identical to futures, except that you don't have to make an isolate call.
Yeah.
The explicit future that I was talking about is one where you simply create an array which is a future. So you don't make a function call, you just say, well, this variable x is a promise. And then anybody who wants to know the value can refer to it, and they'll just block. And any function can fill it in. Right? It's a global variable.
Right.
Anybody can just fill in when they feel like it.
Okay,
so that's just, without making a function call, you just create a single, well, in Aaron Zhu's world, those things are supposed to be single assignment targets.
Mm-hmm.
So you make an array of single assignment targets. The first assignment to each item will release anybody who's waiting for it, locked. The second assignment to it is an error. And that's because he wants to use it inside his highly parallel compiler to allow you to fork off thousands of threads that will work on an array. So maybe they're doing image processing and they're filling in little pieces of it. But if any one of them, if any cell gets assigned twice, it's a sign that your program is broken.
Right.
So the single assignment nature of it is what guarantees the deterministic parameter. You can fork things off and feel safe that everything will be assigned exactly.
Yes. Yes.
Yeah. So that's something we'll be looking at. If you do find a need for that error handler, do let me know, because I wasn't planning to provide it.
Error handlers. Well, I've experimented a little bit with isolates and futures, and when I first hit an error, which was about 2 seconds into the session, I asked Phil, because I knew he was involved in it, and I said, so what's the idea behind debugging isolates? He says, don't ask me, it was Morton's idea.
Well, but Phil doesn't debug, right? Phil doesn't use the debugger.
Exactly.
Even if you read, if the program fails, you read the source code, and you fix the problem, and you start again.
Yes. And to be honest with you, my first feeling was that I'd rather not have to deal with debugging the isolates, because it feels like I'll break something. And it was, I think I'm in line with Phil in the sense that it would be easier to debug the problem in isolation, if you like, and then we run it in isolate.
I came across an example yesterday, actually, of when you might debug. We have this web service that sits there listening for calls from a company that's providing an app to us. And that was helped us, so Chris Hogan helped us set this up. So it works in isolate. So it sits listening for the calls from the app company. and then processes it and returns a result. And it can take more than one at a time because it farms it off into different isolates. The problem is that at some point yesterday, they started sending us something which it didn't understand. There seemed to be some kind of error in the header. It took us a while to find that and to work out how to get back into an isolate, to work out why one particular isolate was falling over. Because as soon as it did, the whole process stopped. This is still in test and development, so that wasn't a big deal. But when it goes into production, we don't want that process to stop. We want it to tell us, I had a problem here with this because of blah. Whether then I want to, just carry on and pick up the next one.
But the default behavior for isolates is that they signal the error back to the caller.
They do. That means that the session stops. In our case, it won't then receive any more calls because it stops, and then the people sending calls into the web service just get unavailable.
You mean one isolate failing
Yeah.
is crashing the main process?
No, it just stops the listening.
So the main process thinks that it's still around.
Yeah. I know we're only to get.
Are you using 14.0 or 14.1?
14.0.
Okay. Because the 14.0 had a problem where, because isolates are implemented using ordinary APL threading, if you have that, there's an option called threads suspend on error. If you have that enabled in version 14, it will stop all, when you get an error in a server, it will stop all threads, including the ones that are handling isolates. In version, and I mean, you wouldn't want to run a server that needed high availability to be running with that option, because any error is going to stop any other threads that you might have as well.
Yeah.
In 14.1, we added a special IBeam that's used by the isolate mechanism, where it can say, I'm a service thread, don't interrupt, don't stop me if one of these things happens. And then, if that is indeed your problem, I don't know. But it sounds like it could be. The cure to that is to, in the tracer, press the green arrow always when you're restarting, the one labeled restarter of threads. Or uncheck the pause threads on error.
We were looking at this sort of thing yesterday. And so I'm still a bit of a learning curve. So
Yeah.
I'll in a minute. But yes, we were looking at the account and
Yeah. There were a few gotchas like that in 14.0 with isolates that we fixed in 14. I mean, I'll talk much more about this in the workshop, errors in isolates and so on. It's working okay now.
So explicit features, version 16? Or?
No, I don't think so. I mean, that's not actually what you're looking for. You're looking for futures. What you showed me here, as far as I can tell, are just completely ordinary futures. You're making a function call and getting a future back.
Yeah.
The difference is that you just want to launch it in a separate thread. Maybe we could provide a mechanism to allow you to do that. Run a function, return a future.
It's basically a simpler version of the isolates feature. So,
well, it's a future without
the
isolates. Yeah, it's a future without isolates. Yeah. And the tools that Klaus was showing, part of what they were doing was delivering that kind of functionality. Futures, I mean, these latches and so on are an even more explicit way of expressing you want to wait for something.
Yes.
The whole point of futures is that you don't need that explicit stuff. You just refer to the data and you block until it's available.
Yeah. We can do that today. Just not that as neatly as you could do it.
Right. Yeah.
Right, that's me. Look,
okay.
I think I beat even Klaus shortest. Yeah?
In Jquery, chaining allows you to take different functions belonging to the Jquery function to chain them together into a sequence of expressions, where the point is you don't want any of the intermediate results. In your examples, you've been catching, assigning the intermediate results, and then pass P1, P2, and passing them on. But it seems clear that you could syntactically just chain them together in a jQuery-like style, not preserving the intermediate results. And I think I infer from what you say that you intend your error handling to continue to pass something along to continue processing. So if you've got, as in your example, you've got an error in the calculation of P2, the error function, the error handler would pass on something that P3 will work on.
Yes, potentially, if it's possible.
I guess I should say that the obvious objection to chaining in this way is, well, Stephen, wouldn't you just put everything into one big function? When I asked you that a few days ago, you said very plausibly the sort of processes that you want to turn into promises are things which might be using the file handling system or whatever, and you don't want to break down in the middle of several of these things. You want to encapsulate each one so that it's the error handling for that is relatively simple. Trying to envisage how, if you chain together 3 or 5, as you might do in a jQuery chain, promises like that, and you've got different errors in different strands through those, where you'd see would you see all the 3 or 5 promises being fulfilled before the main processes gets to look up for what happened, or would you intervene before that if you're not getting intermediate results through them?
You're saying in the example where I had 3.
Yeah. I'm inviting you to imagine them all chained together.
Yeah.
Without catching.
Without assigning the names, but still being able to provide error handlers on each level.
Well, is that just a bridge?
No, well, you can do that, but you don't need those variables, right?
You don't need them.
You can just
it's
go
just very
left
awkward.
tag, paren, something, dot then. It would get a bit nasty.
Yeah, I mean, what I've seen in the JavaScript world, the chaining is very pretty in JavaScript because it can pass references to functions. We can't do that easily in APL, which is why I've resorted to operators. Even then, I'm not prepared to show the source code because it might throw a few questions. But being able to catch references to functions and pass them around would have been lovely to have in APL, whenever that's being provided to us. With resorting to operators, chaining it doesn't look syntactically pretty because...
Why do you need the operator there? That's only because you want to provide the error handling function, right? If you didn't provide the error handling function, then you could just... well, at least you could write it then, dot then. No, it would be an operator.
Yes.
But you could just put parentheses and then say dot then.
Yes, but that's what I mean. This nesting, even if I use the monadic approach and not use a dyadic operator, the whole business of nesting the calls to lookup, which is why I named them. But yes, in theory, you don't need to name the intermediate ones. I haven't found a good use case for when you would have 5 levels of chained promises and the middle one broke down. What would the last few do if it broke in the middle? And the only, I mean, it's similar to the problem with defans where trapping, putting a guard or a trap in a defan doesn't catch errors in a nested defan or nested traditional function, which means
if you had real futures, you could just write that as, if you had something that made a future, what shall we call it? Ampersand underbar, yeah?
Yeah.
2, 0, minus 2. And you just need to say, you can just say 1, your next function. Just pass it through. You
Right.
wanted that to be a future as well. You do that.
Yeah.
You can chain them that way.
Yes.
I mean, APL chains that way, right? JavaScript says, foo dot goo dot who, and that's chaining. It goes that way. APL chains that way.
Right. The difference between this is that this doesn't allow you the error handler.
No, that doesn't allow you the error handler.
And yes, you could write this using promise.new. It's the same thing.
Yeah.
It's just a shorter symbol for it.
Yeah.
But this would work, yes. You could chain them in that fashion if you repeatedly called the future operator. But no, I don't know exactly what I would expect it to do if it broke down in a chain like that. I'm not sure if there is a...
I mean, perhaps that's the point of the error handler, is that you can do something specific at each point in the chain by providing a different error handler for each one.
Yeah, if divide by 0 didn't work, then return 0, which would be okay in the next step in this scenario. Read a file, failed, return an empty string. I mean, it's difficult to generalize. I'm not sure how useful it would be. If it's a critical operation halfway through, then presumably signaling an error up the or down the tree is the correct thing to do.
But the 0 works, the error handler.
Yeah. Why not? Thank you, Kai Egger, for Present APL, which has made it easier for me to create my slides. I am allergic to PowerPoint. And writing the syntax for, well, the syntax for this presentation is
presentable.
Presentable. Well, that was a bit slow. Did it even open?
It's an HTML generator of some sort.
Yes. Kai, do you want a few minutes and actually present it yourself?
No.
No?
Just one word. It is Markdown converted into HTML5.
Right, so this is Markdown in a little
It
file.
doesn't need explanation. It's so simple.
It doesn't need explanation. So it takes your router or notes and converts them to HTML and also wraps them up with some style sheets, simple JavaScript to deal with the transitioning between slides. And it's easy to edit because it's a simple text file. It's easy to shift things around quickly and version control, etc., etc. You can do much more than I have used, and actually Kai criticized me for not using enough features in my presentation. But typical things I do. If they are in a GIF file, then yes.
Right.
I'm not sure if that's what you
I
meant.
may stick with PowerPoint for a bit.
Yeah.
A
Well,
quick check, who in this room uses Markdown? Jerry, stick your hand.
You don't.
Okay.
well, I've sort of started.
Yeah, I will just give it this one.
The reason why I'm not after telling something, because I haven't prepared something, and the second one is I'm going to give a presentation on Markdown and the underlying software converting this into HTML5 in Glasgow.
So you want to have something to show that hasn't been...
Well, I'm just not rendered, including, for example, a style sheet which emulates the output of the vector. So writing a vector article with Markdown is much easier than it has been in the past.
Right.
Despite Jake's diffidence here, we are, I think, seriously looking at using Markdown as the preferred submission format for vector articles, as it converts automatically into XHTML And we're going out using Markdown as the source for writing Dyalog cookbook. Recommended.
And by the way, is anybody using Git?
Any
Have you
bits?
ever written a comment on Git, on StackFlow or SourceForge? If so, you're using Markdown without knowing it.
I have
That's all right. We'll just record your sound. Right, thank you everyone. The next presentation is for privileged attendees only. So those of you on the web, you will see the presentation on the webcam, but it will not be, this screen will not be captured because of technical difficulties. So if you're on, you'll see it, but if you hope to see the presentation later on, all you will get is an audio stream. Doesn't affect you guys here, don't worry. Okay, right.
so speaking already. Actually, it was set to have a coffee break now, but we are actually half an hour ahead of schedule. So,
Well, it's only 2 o'clock. So if you're ready, then I suggest we do it now, and then after the coffee break, we do the workshop.
Yeah, I mean, I'm easy.
In which case, let's.
Have a slightly longer coffee.